What we're taking a look at here today is solving quadratic equations using square roots. And before we get to that, we're going to just review a few key concepts that are going to help us moving forward through the next few lessons. The first concept, going through and solving a linear equation. So if we had something like 2x minus 4 equals 0, we're going to go ahead and use inverse operations to isolate that x variable. We'll work outside in. The inverse operation of subtraction here would be addition, because those two will cancel each other out or undo one another. What I do to one side, I have to do to the other side. I would have 2x equals 4, and then I would divide each side by 2. I have multiplication here. The inverse operation would be division. X would equal 2. Now, the second question. What is the x-intercept in the graph to the right? So if I look at this, the x-intercept is this point right here. It's where my graph intercepts the x-axis. It would be at the point 2, 0. Now, how we run about doing that? In the equation, y equals 2x minus 4. Just like we did when we were graphing linear equations in standard form, we're going to go ahead and we're going to set our y variable equal to 0 to solve for our x-intercept. The reason why we know we can do this is if we have a y value that is set equal to 0, we know it has to be across this line, which ends up being our x-intercept as well for our graph. So we're able to go ahead and do that and go through and solve this to isolate x, which would be the same exact way we did up here. We would use inverse operations, add 4, because those two would cancel. 2x equals 4, we would divide by 2. X would equal 2. And what that means in relation to this problem is that our x-intercept would be at the point 2, 0, which we also see on the graph here. Again, all of these problems connect. It's just understanding, again, that if we want to find the x-intercept in a graph or an equation, if we're graphing something, we want to set the y equal to 0, and then we go through and isolate x to go ahead and do that. That's going to be key. When we say something like this that says solve, we're really talking about finding the x-intercepts. So to do that, we're going to set y equal to 0 and go through and try to isolate x to get it by itself. There we go. All right, so we want to get x by itself. Again, we have subtraction on this side. We're going to add 9 to both of these. Would cancel. X equals 9. What that's telling me is my x-intercept is located at x equals 9. So I can go through 1, 2, 3, 4, 5, 6, 7, 8, 9. I know I'm going to have an x-intercept at that point, and I have a slope of 1. Looking at this, I would go up 1 to the right 1. And I end up having a straight line. This is a linear equation. This is what it's going to look like. We have one x-intercept, because there's no way, if it's a straight line, that it's going to bend its way back up and intercept again. So we know we're only going to have one, well, at most one. Now, what we're going to start looking at, we're going to solve quadratics in the same exact process. We're looking for the x-intercepts. So we're going to set y equal to 0, and we will go through and isolate x. Same exact way as we would in linear equations to start. Now, when we get to this point, what we have to know, this is not multiplication. It is not x times 2. This is x squared. It is an exponent. So when we identify that, we know we're going to have to go about doing something different. We do not divide by 2 here. What we actually do, like we mentioned in class, and we've talked about other times throughout the year, is we're going to take the square root, because the square root is the inverse operation of squaring something. If you think about it, if I look at the square root of 3 squared, 3 squared is 9, and if I look at what the square root of 9 is, well, that's plus or minus 3. Now, from this step, we could have just canceled both of these and ended up with our 3, and would have given us one of those answers for that. Now, looking at this, when we get to this point, that means the square root and the square, they're going to cancel each other out. I would have plus or minus 3 as my solution. With that being said, what that means, these are my x-intercepts. So if I were to take a look at a graph for this quadratic, I should have x-intercepts at 3, 0, which I do, and negative 3, 0, because my 2 points that I found here, 3, 0, and negative 3, 0, again, remember we said y was set equal to 0 to start the problem. And I see that in connection with this graph as well. I see that my x-intercepts matched what happened when I solved this equation with y being 0. I'd be able to go through and do that. Again, this is the same exact concept. And when we look at quadratics, it makes sense. We can have two answers. Just because of the shape of the U, it can intercept this at 2 points. It can also intercept it at 1 point or 0 points, which is something that we will get to moving forward. So what we want to do here is we want to solve these quadratic equations. And to do that, we're going to isolate the x variable. Just like we would with any linear equation, we want to get x by itself. And we're going to use inverse operations to do that. So we would add 47 to each side here to undo the 47. X squared would equal 64. I would go through and I would take the square root of each side because that is the inverse operation of squaring the x. So those two will cancel each other out. I have x equals the square root of 64. I take what that is. Again, remember square roots, we're thinking what times what gives me the number underneath this, or what times itself, I should say, gives me the number underneath the square root sign. And we should have two answers. In this case, it's plus or minus 8. Now this one worked out nicely. The second one, we jumped right into the square root of each side. And just like we've been doing the last few days in class, we're going to break down this 12. Remember, there's the two ways that you can go about doing this. You can either use prime factorization and go through 12, get 4 and 3, 2 and 2, and we look for pairs. Here's our pair, and then we kind of continue that from there with that process for breaking this down. Or we can end up looking at this and say, all right, well, I know I could break this down into the square root of 4 and the square root of 3. Square root of 4 I know is plus or minus 2. And I would have the square root of 3 left underneath the square root sign. Again, however makes sense to you. We could use the prime factorization way to do this, or we could just use number sense and identifying factors to do that. But either way, this is the key step, taking the square root of each side for those. Now, what I want you guys to do, try these two. Go ahead, try them, pause the video to do this, and check your work when you come back. Alright, so hopefully you paused the video and you went through and you did these two examples. Now, if you take a look at example 3, again, we're working outside in, just like we would with linear equations. To isolate the x variable, we subtract 7 on both sides. We would divide by 2 because those are our inverse operations. We get x squared equals 36. Then we go ahead and do the square root, which gives us plus or minus 6. Again, we have two answers for this. Same thing in number 4, we would subtract 7 on each side, then we jump right into the square root because we've isolated x. And just, again, when we don't have something that breaks down easily like square root of 36 like we had over here, this square root of 50 we could use either prime factorization like we do over here, method 1, or we could just use our number sense. And again, that's all things that we've been practicing. Those are in the other videos, and that's all stuff that we've had plenty of time to practice. So we pick whichever method, or you choose which one makes the most sense for you and which comes easier. But that's that. That's solving quadratic equations when we only have one x term. When we have an x squared, we can go ahead and we can do this. When we have like x squared and an x and a con, you can't go ahead and do this. You have to use factoring or some of the methods that we're going to use in later videos. But understanding, like we've talked about in class, when we have just the x squared and that's it, this is a method that we can use, just like solving linear equations.